Hey guys, today we're still talking about some features of polynomials, but we're going to do a couple more vocabulary words. And the main one here is going to be extrema. So we're asking ourselves, what is the difference between relative and absolute extrema? So let's start by looking at a picture of a polynomial. Okay, so here is some random polynomial. I've just graphed it, and we're going to find some interesting things out about this graph. Now, before we start, we kind of need to know some of those vocabulary words. So an extrema is just a high or a low point on a graph. So when I say find all of the extrema, you're just telling me where are the highs and lows. We've been used to seeing like quadratics where they only have that one high or low, but now we're going to see graphs that kind of looks like this graph over on the left where there's multiple points where that graph has like a high point or a low point. So something interesting about extrema is, for example, this isn't actually the graph that's graphed over to the left, this equation here. But if I'm given an equation, I can tell you how many extrema it can have at maximum by doing something with the degree. So if you remember, the degree of the polynomial is the highest exponent in there. So for this one, it's 3. And if I take that degree and I subtract 1, that tells me the max number of extrema. So how many highs and lows this graph can have. Now it doesn't tell you if it's a high or a low, but at least you could have an idea. So for instance, this one right here, 4x cubed plus x squared minus x, would have at maximum 2 high and low points. Okay, now there are 2 different types of extrema, and there are 2 subdivision underneath that. So the first thing is called an absolute extrema. And what that means, it's the highest maximum or the lowest minimum on a graph. So when I'm looking at an absolute maximum or minimum, when I was talking about those quadratics, they had one of those. This quadratic, this parabola would have an absolute minimum. There's a lowest point on the graph. Now, if I look over here, though, I notice that there's this low point, but there's also an arrow that says this is going forever. So this graph doesn't actually have a maximum or a minimum for absolute, but it can have what's called a relative or a local extrema. And so a relative or a local extrema is the highest or lowest point in an area on the graph. So looking at this one, you can see there's some spots where there's definitely highs and lows. Just because they're not the highest or lowest, we still have some on this graph. So if I look at this graph, I'm going to use blue. If I'm looking for example, and again, we're looking at my picture that I've drawn so lovely over here, I can say that there are maximums on this graph. Any of these high points are considered maximums or extremas. So I would say that this right here, these two, these are relative or local maxes. And so when I label those points, I just name them how they're called. So this would be -7, 0. And then this one up here is up at 1, 5. So there are maxes on this graph. Okay, now I also have some minimum points, some low points on this graph. So these two right here would be my relative or my local minimums. So if I was to list out those mins, I would say I just name them by the coordinates. So -3, -5, and 6, -2. So so we can have maxes and mins even if my graph goes on forever, even if it has arrows at the end of it. Okay, the other thing that we need to know here is something called increasing and decreasing. And this is super important when you get to calculus. So definitely pay attention here. So really what we're looking for when we're looking for an increasing spot of the graph, you just want to know where is my graph going up? Where, if I had a line, would it have a positive slope? Now we're going to be dealing with a lot of curves, so technically it's not going to be a perfect slope, but where is my curve going up? So really for increasing, we want to know where there is a positive slope. So if I look on this graph, this piece has a positive slope, this piece has a positive slope, and then at the end it has this positive slope. So when I'm labeling these though, I only want to know the intervals on which the graph is increasing. So I don't have to list where the x and y values are. On these guys, you're only going to be listing the x values of your mins and maxes. So you do have to find all those relative mins and maxes to tell me where it's increasing and decreasing, but you only are listing the x value. So if I look right here, we're going to write this in interval notation. So since there's an arrow down here, I know that it would be increasing from all the way up to that spot. So from left to right, from negative infinity up to this point, it'll be increasing. This x value is negative 7. Now the weird part about this is we're going to continue to put these little parentheses. We can't equal that point because technically this point is neither increasing nor decreasing. It's at that 0 point. So we're just going to leave it alone and put that. There's more than just one interval it's increasing, so I'm going to put union, and then I'm just going to write again where it starts using parentheses. So negative 3, and then it's going up until 1. Remember, we're doing x values here. And then there's one more section, and again, it starts again at 6, and then it's going to go all the way. Again, there's an arrow, so infinity. Okay, so same deal with the decreasing. Now we're just looking, where is my graph going down? Where would my graph have a negative slope? So there's a piece there, and there's a piece there. So I would go, say, from negative 7 up until negative 3, and then union up until 1, and then to 6. And then that would be where my graph is increasing or decreasing. So we're just listing out the intervals where my graph would have a positive slope, where it's going up, or where it has a negative slope, where it's going down. And then I'm just telling myself, where are those x values? I don't actually care what the y values are. I just want to know, where are those x values on that interval? Okay, I have one more example. We just go over a little bit more. Okay, so I have a picture here, and they're asking me to find all my maxes and mins, and then they're asking to tell where is it increasing and decreasing. So again, you're looking for, where do I have those turning points? So if I look, I have one right here, and I have one right here, and one right here. We're going to have to estimate a little bit since there's no grid. So since I have these two right here, this would be a min. It's a low point, and this one is also a min, because again, it's that low point in that area. So if I name this point, I would say that that's at about negative 1.5 and negative 4. And then I have another minimum over here, and we're just going to say that's at 4, negative 1. Again, these are intervals. These are just points. So this is a coordinate of a point. These will be intervals down here. So when we're looking for maxes and mins, you're just looking for points. Up here, this would be a max, because that's the highest point in that area. And I would say that that is at 2, 0. Oh, that one's nice. Okay, I can't really say that there's an absolute maximum because there are arrows at the top. Although technically on this graph, there is an absolute minimum. It's down here. This is the lowest that this possible graph could go. So if you wanted to make a note, you could say, yes, this is definitely the lowest point on the graph. Okay, so then when I go find my increasing, decreasing, again, I want to see, where is my graph going up and going down from going left to right. So this part is going down in the beginning. Okay, then it starts to go up, and then it goes down a little bit, and then it starts to go up again. So when I'm labeling my increasing, I looked where I just did green, where it's going up. And again, I want those x values. So that starts at negative 1.5, and it goes until my graph hits 2. I just put a little parenthesis, and I shouldn't have. I got too excited. Okay, so 1.5 to 2. Then union, because I know there's more green on my graph, I'm going to start again at 4, and then it goes all the way up until infinity. Okay, and then the decreasing is the part where it's going down from left to right, so where I did red. And again, that starts on this part where it has an arrow, which means that it's going forever in that direction up until negative 1.5. And then it starts again at 2 to 4. And if you notice, a lot of times your intervals will kind of not overlap, but they use the same endpoints because that's where those mins and maxes were. Okay, so that's all I've got for you. Just basically figuring out where you have important features of your graph, like maxes and mins, and telling yourself, where is your graph increasing or decreasing.